Hello, hello. Thank you all so much for coming. I would like to welcome you to our next part of the OpenShift World Tour series, Secure OpenShift Applications with IBM Cloud App ID, App Security Made Simple. So before we get started, I'd like you all to take a moment to introduce yourself in the chat. So feel free, no pressure, to share your name and pronouns, which title or company or program you're currently with, where you're from, or maybe where you're joining from during quarantine, something you love, and then a quirk, something that's uniquely weird or different about you. So I'll go first, for example. So my name is Jenna. My pronouns are she, her. I'm a cloud developer advocate with IBM. I'm originally from Detroit. I'm also joining from Detroit. So I've been in Austin for the past few years at the IBM Innovation Center there. And since COVID, I've been working from home in Detroit. Something I love are my dogs. I have little Yorkies. You may or may not hear them being annoying during our session, so feel free to ignore. I will be shushing and shooing them as much as possible. And then a quirk, something uniquely weird or different about me. So I have an obsession with tuna melts and tuna sandwiches. I try them everywhere I go. I'll specifically drive out of my way to try a tuna sandwich at a restaurant. If it's bad, I will write off the entire restaurant completely. I'm a detail-oriented gal. So if you're not willing to put a lot of love and effort into your tuna, I don't really want to see what you're doing to the rest of your food. So that's a little bit about me. So feel free to share in the chat. Also, just to give you all some general housekeeping, just to get everyone on the same page. If you look at the very top of the chat, what I have listed here for all of you, I have the link for the IBM Cloud sign up. If you would like to follow along, you will need an IBM Cloud account for that. It is completely free. You won't be charged at any point in time. I also have the link for the event slides and the link for the live stream recording. So this is being recorded to multi-streaming to another number of platforms. So the recording will live at the same link that you joined with today. So whether it's on YouTube or Facebook or Crowdcast, the link that you joined with today is where the live stream recording will live following the event. I also have listed here some IBM Cloud certifications. Those also are completely free of charge to you always. I'll introduce those in just a second. If you're having any trouble at all watching the Crowdcast, go ahead and refresh your browser. That's if you're seeing a blank screen or something's frozen or you're not hearing anything, make sure to refresh your browser, and that will fix the issue for you. If you'd like to follow me on social or see some more content, data and AI, cloud native, OpenShift, or other, you can connect with me on any of my socials at jwritten. So again, these links are at the top of the chat, the slides, the live stream, and the link to create an IBM Cloud account. So when you go to create your account, this is what you'll see. And again, we have over 40 light plan services, things like Watson Studio, Kubernetes. We have light tiers available for you to use. They're at no cost to you. And for instance, for the OpenShift clusters and some of the other services that need to be provisioned, for some of those, they will automatically delete after 30 days, so you won't get a charge for those. So to start, I have a few badges that I've personally gone through the training for. I've added them to my social profiles. They're really useful. So if you're getting started with cloud native development and you're looking to kind of level up your skills, this is a good place to start. So this is the Cloud Essentials badge. The next badge following is the Cloud Application Development badge, which introduces you to cloud native application development. Start to get your hands dirty a little bit. And then we have the Applied Cloud Development badge. So this is more hands-on cloud native application development. So this one's really fun. Again, I've listed these in the chat as well. Highly recommend. I've worked through all of these, and I thought they were really, really useful. So I would like to do a temperature check. So first of all, I have a poll question. Let's see. Okay, so the first poll question I have here is, have you worked with containers? So there is a poll at the bottom of your screen there. So go ahead and just vote yes or no. There we go. Very cool. Okay. So first thing I want to start with today for you all is just to do a very brief high-level overview for anyone that's new or not familiar, and more of an overview for those of you that have been working in the container space. So first of all, what is a container? So a container is just a standard unit of software that packages up all of the code and all of its dependencies. So the application has the ability to run quickly and reliably from one environment to another. So to bring some imagery to things that can be kind of abstract topics to talk about, this is what we're referring to when we're talking about a container. So we have our host operating system, we have our supporting files and our runtime, and then we have our applications that are running on top of that. So containers are available for both Linux and Windows-based applications. Their containerized software, the containerized software will always run the same regardless of the infrastructure. So what's really nice about it is that you can have teams working on projects with different local dev setups, people working on different machines, Windows and PC or Linux. The containers are going to isolate the software from the environment, and that's just going to make sure that it works uniformly despite any of the differences, for instance, between developments and staging. So this is something that we're going to see as we work through the lab. So I just wanted to introduce it. So what is a container image? And when we're referring to an image, what does that look like, right? I don't like to work with abstract topics. I like to be able to see and touch everything I work with. So as you can see here, we have our image layers. We have read-write access to our top container layer. We have our previous version layers below, and this is all within our container. So a container image is just a lightweight, standalone, executable package of software that includes everything needed to run the application. So the code, the runtime, the tools, the system libraries, and the settings. So container images actually become containers at runtime. And in the case of Docker containers, images become containers when they run on things like Kubernetes or Code Engine. So that's just a kind of a high-level overview. Container registry, we're not going to touch too much on this, but I just wanted to introduce it to you. So when we have all of these container images, right, where do these things live? So one place that they live is within a container registry. So there's two types of registries. They're public and private. So public registries are great for people, individuals working or small teams. They want to get things up and running quickly as possible. Private registries provide a way to incorporate security and privacy into enterprise container image storage. And they're hosted remotely or on-prem. So for instance, we have a Docker image registry. Red Hat has a container registry called Quay, and IBM has a container registry as well. So just to for reference, I would like to ask well another poll question. So take a peek at the next poll question. So how many of you are familiar with OpenShift? So if you're familiar with OpenShift, go ahead and vote yes. If not, go ahead and vote no. So the first thing we're going to talk about when we talk about OpenShift is Kubernetes. What is Kubernetes? So Kubernetes is also known as K8. You may have heard that term thrown around. It's an open source system for automating deployment, scaling, and management of containerized applications. So those container images that we saw before. So this is kind of, as you can see here, this is kind of what it looks like. We have our Kubernetes. We have the scheduler, controllers. We have making calls to our API server, and then we have different nodes containing our kubelet, our kube proxy, and our pods at the bottom there. So very high level, Kubernetes groups containers that make up an application into logical units for easy management and discovery. So Kubernetes, again, also known as K8, you may have heard that thrown around, is an open source system for automating deployment, scaling, and management of those containerized application. So it basically groups containers that make up an application into units to make it easier to manage. So what is OpenShift, and how are these things kind of all connected and playing a role together? Cool. So Red Hat OpenShift is a Kubernetes distribution. It's focused on developer experience and application security that's platform agnostic. So OpenShift is going to help you develop and deploy applications to one or a number of hosts. They can be public-facing web applications or web backend applications. It includes microservices or databases. So applications can be implemented in any programming language, right? So it's platform agnostic, it's language agnostic, right? So it doesn't matter if it's Python application or a Java application or React or TypeScript. Any application can run on OpenShift. The only requirement is that the application can run within a container. So if you can create a container image of your application, then that's the only requirement for being able to run your application on OpenShift. So in terms of cloud computing models, OpenShift implements the functionality of both a platform as a service and a container as a service. So using OpenShift as a container as a service, you can bring a pre-existing container image built to the OpenShift Container Initiative image specification or image spec and deploy it. So you can create new or bring existing container images. And let me, should have moved forward so you could see this. Okay, so this is taking the abstract and putting some structure around it. We have any infrastructure, as you can see there at the bottom. So we have physical, virtual, private, and public. We have our Red Hat OpenShift container storage. We have our Red Hat Enterprise Linux core operating system. We have Kubernetes running on top of that. We have our automated operations. And then at the very top here, we have our cluster services, such as monitoring, showback, registry, logging. This is best for the best IT ops experience. In the middle there, we have application services, such as middleware, functions, and ISV, and service mesh. This is our container as a service and our platform as a service. Also, you may have heard, you know, a little bit about serverless. That's what we're referring to when we're talking about that FaaS there, that functions as a service. For the best developer experience, we have developer services. We have dev tools, automated builds, CI/CD, and IDE. So the platform as a service capabilities of OpenShift build on top of the ability to deploy a container image by providing a way for you to build in OpenShift your own container image direct from your application source code and have it deployed. So maybe you don't know how to create an image, a container image, or you haven't done it yet. What's really nice with the platform as a service capabilities of OpenShift is that it can do that for you. It can create a container image directly from the source code of your application, so like your Git repository, and deploy it. The application source code can include a Docker file with instructions to build a container image, or you can use a source to image builder, which is what we're going to see here today, which takes your application source code and converts it into a container image for you without you needing to know how to write instructions for building a container image. Let's see. So my last temperature question here, I'm going to make it visible for all of you. There you go. Is, have you worked with application security in any capacity? A little bit looks like we have a few people. We have other people who haven't worked with it yet. Very cool. Okay, good to know. So the first thing we're going to do before we dive into the hands-on lab part, and if you haven't already, please take this time to use the link. Let me update this for you. To use the link at the top of the chat or the link at the bottom of the screen that you see right there. It says IBM Cloud Sign Up. Use this time as I'm going over kind of an overview of our IBM Cloud App ID security. Take that time to create your IBM Cloud account so that you can follow along with the lab portion. You can do it on your own time after if you would like to just watch and follow along that way. That's fine too. So the first thing when we're talking about application security, we're talking about authentication and authorization. So App ID is a security step for protecting resources, and authentication is in general. So you may have heard of OAuth or different types of authentication. So any means of authentication is just a step for protecting the resources for your application. Are the users who are using your application who they're claiming to be? And then what can they access, right? You probably don't want to give every user of your application admin access to your application where they can be installing malware or accessing other users' data. So regardless of whether your application is web-based, mobile, or cloud native, you probably need to add some sort of login functionality to either limit access to the application or backend resources, and even to further customize the overall app experience for your users. So for instance, when you go to a website and you log in with the LinkedIn login or the Google login, right? These are all different ways of, different methods of using authentication. Okay. So this is where the authentication and authorization comes in. So when we're talking about authentication, we're referring to the process of confirming identity. In authentication, a user or application proves they are who they say they are by providing valid credentials for verification, which is often through a username and password, sometimes combined with other elements called factors. So for example, single factor authentication is just a password. Excuse me. Two-factor authentication is a password in addition to a piece of confidential information, such as entering in a code that's sent to your email or your mobile phone. Multi-factor uses two or more security factors, such as using a password and also a security code to the user's cell phone. So in addition to, so when we're talking about two-factor, sorry about that. When we're talking about two-factor authentication, for instance, when you log in and it's asking, you know, who was your, you know, favorite teacher growing up, right? That's that extra piece of confidential information. Multi-factor uses two or more security factors using a password and also a security code. So for instance, when you log into your bank account and it sends you a text message with a code, and then you enter in that code along with your password to log into your account. So authorization comes after when we're talking about authorization, this is going to come after a successful authentication, and it's going to determine what the users can and cannot access by an access token. So we'll talk a little bit more about that. So some basic concepts when we're talking about authentication. We're talking about OAuth 2.0, OpenID Connect, and JSON Web Tokens, such as access tokens and identity tokens. So under the hood of authentication and authorization are the following basic concepts. So OAuth 2.0 or OAuth 2 is the open standard protocol that's used to provide app authorization. OIDC is an authentication layer that works with OAuth 2. OAuth 2.0 is about resource access and sharing. So a way to get basically a way to get an access token. And OIDC is all about user authentication. A JSON web token is a way that the access tokens and the identity tokens are represented. So OAuth 2.0 authorization framework has several flows, which are referred to as grant types, to get an access token. So implicit flow returns the access token in the URL directly, rather than being returned by a trusted back channel like the auth code flow. So the access token itself will be logged in the browser's history. This flow isn't really recommended anymore for client-side applications because it has some security flaws, and will show kind of the current industry standard for single-page applications. So just keep in mind, when the application makes the request for the access token, that request is authenticated with the client's secret. And this reduces the risk of an attacker intercepting the authorization code and being able to use it themselves. So a key part of that authorization code flow is the assumption that your application can securely store your client's secrets. So public clients or single-page applications are unable to securely store these secrets because the application is run entirely in the browser. So a new flow is needed for this use case, and this is where the implicit flow comes in and why that was created. So the way it works is after a user successfully authenticates, as part of the authorization response, the implicit flow directly returns an access token. So as you heard earlier in the authorization code flow, instead of returning an access token, an authorization code is returned, which can then be used at the token endpoint to get the access token. Implicit flow returns that access tokens as part of the URL, like we talked about. Tokens can be, this is how tokens can be intercepted, and they can be accessed. So the tokens might be saved in a user's browser history or logs. So the history or logs might be stored in a cloud service and sent to multiple devices, which provides an even greater amount of risk. So if that's not enough of a security risk, implicit flow is also susceptible to a redirect URI attack, which means an attacker might replace an approved redirect URI with a destination of their choice and redirect you to a space where they can then steal your information. Okay, cool. So when we're talking about PXE, and I have a picture for you on the next slide. So this is the new recommended method for securing single-page applications, and that's using the authorization code flow with proof key for code exchange, so otherwise known as PXE. So that's proof key for code exchange. It's an enhanced authorization code flow that replaces the client secret with a code challenge and a verifier. So the code verifier is a cryptographic random key that's unique to each authorization request. Specifically, it's a string with a minimum length of 43 characters. The code challenge is derived from the code verifier, and the challenge is in the encoded version of the code verifier. So a challenge method can optionally be sent with the code challenge. If it's not present, then it will default to plain. A more secure option than plain, however, is to use S256. And if you're curious about learning more and kind of getting into more of a security deep dive, I have some links for you to check out too. So this is a diagram of how PXE works. So the application makes an authorization request to the server. It includes the code challenge. Optionally, it can include the code challenge method as well as at the step. The server is then going to return the authorization code, and later on when the application is making a request to the token endpoint, it includes the code verifier. Before returning an access token, the server is going to confirm the validity of the code verifier, and if it's valid, access is denied. So the important piece to take away from this diagram is that the utilizing PXE is an addition to the authorization code flow. So we're going to be securing an OpenShift application with IBM Cloud App IDs, but you know, what exactly is it? So, since authentication and authorization can be risky and complex, we want to use an identity service such as App ID to handle the complexities for us so that we don't need to be security experts in order to implement this and have security. So App ID is a really great tool for developers to be able to focus on their building and deploying their applications and really focusing on the content of what they're meaning to build without having to take too much time to deep dive into learning how to implement security. So IBM Cloud App ID is a great developer's tool for handling all of these pieces for you: the authentication and authorization, user profiles, user management, and it's essentially identity as a managed service. So the first feature of App ID, again, we have authentication that we talked about. So profiles, we have the ability to build custom app experiences for your users. We can store and access user data that you might need to build engaging experiences, such as user app preferences. When we talk about user management, we're referring to leveraging a scalable user registry for your applications, so users can sign up and sign in with an email and password. Users can also manage their own accounts through self-service flows like reset password and forgot password. So that takes care of a lot of tedious pieces in building application security into your products. And the last part is identity as a managed service. So with App ID, You don't have to worry about setting up infrastructure for identity, ensuring geo-availability, compliance. App ID is also integrated with IBM Cloud, with IBM Cloud Kubernetes Service, Cloud Functions, Activity Tracker, and more. So you can really seamlessly integrate App ID into any of the IBM Cloud services that, that you wish to use. Here we go. So this is just an overview diagram of How App ID works. So it's a service to add authentication and authorization capabilities to your applications. It connects identity providers to your application in an industry standard way. And then just some use cases for App ID. So the most common is web applications. So for web applications, App ID uses the OIDC authorization code that we talked about earlier. We have a Node SDK. We also have a number of other SDKs which can be used with web applications as well. The mobile flow, as you may have guessed, is useful for when you're developing apps that will be installed on a user's mobile device. And we have both an Android SDK and a Swift SDK for iOS that can be used for mobile applications. So that's really nice. Let's see. So the last piece is multi-cloud applications with Istio. So this is for applications running on a cluster that we're going to look at today. App ID utilizes the app identity and access adapter, which enables App ID to control authentication and authorization policies in all of the environments that your application is currently running in, including front-end and back-end applications. And it does all of this without any code change or redeployments of your application. So here's a diagram, and I have some information here too if you want to take a little bit of a deep dive into App ID and security. And then here is the App ID SDK. Now, what you will need to, there's two things you're going to need to follow along with the lab today. The first, like I said, is the IBM Cloud free tier account. And the next is the link to the OpenShift labs. So let's go ahead and get started. So again, you'll need to create an IBM Cloud account. I have created a demo account. So that I can show you from an external account of exactly what you need to do. So when you open up the OpenShift lab link, this is what you'll see. And if you scroll down, you'll see the application security link here. I also have extensive notes and images to follow along with the lab as well. So what's going to happen is we are going to provision a cluster to work in this lab. And what's really nice is you can do this individually. You don't need to enter in any keys or anything like that. So I'm going to show you exactly how to do that. Okay, so here. Okay, here we go. So we're going to go to this application security. I'm going to click Launch Lab. Okay, and then we're going to come here. It's going to say, do you already have an IBM Cloud account? We're going to sign in. Okay. So what's really nice is this is going to set up a dev environment in the browser for us within our IBM Cloud account. So we don't need to spin up anything or do anything. We will need to create an IBM Cloud App ID instance, and we'll do a little bit of work there. But as far as getting your lab set up and making sure you have things installed locally, any of that, you don't need to worry about any of that, because we're going to do everything inside the lab space here, inside this terminal here. So I just want to make sure that you can, you're able to read and see everything. And it's big enough for all of you. Let me just get a drink of water. Okay. Okay, so by now, your OpenShift lab should be provisioned and ready to go. Let's go here. Okay. So what we're going to do today is we're going to create a web application deployed to an OpenShift cluster, and we're going to secure it with OpenShift. We're going to create a user profile to log in. And like I said, we're going to do everything within our terminal here, so we don't have any issues with dependencies or wrong node versions or anything like that. So everything will be taken care of for us here. So this lab's going to allow us to do a few things here. So it's going to allow us to provide the UI through the web browser and leverage external authentication services through our IBM Cloud App ID instance. Specifically, the web app is going to leverage, as we mentioned before, the OIDC Authorization Grant Type. So we are going to create a Java microservice that implements the backend for front-end, also referred to as BFF. We will see that as we work through our lab. The BFF, so backend for front-end pattern, and the OIDC integration are implemented using the Spring Boot framework, Spring Security related framework. So these are things kind of going on in the back end. So the backend for front end is a microservice. It's packaged as a container, leveraging Eclipse JKube. So this is an automatic source to image, like we talked about earlier, and it's going to be deployed to Red Hat OpenShift on IBM Cloud automatically, so we don't have to worry about doing that. We're also going to see the Java resource microservices returning a simple message. So our microservice is implemented by using our Spring Boot framework. And lastly, our microservice to microservice security between the backend for front end and our resource microservice is going to use the OIDC JSON web tokens and the Java web key set public keys. So you can access the application that it was based off. It's a Spring Security and Angular application. There's a sample application in the Git repository here. But again, you don't need to clone any repos. You don't need to do any of those things. All of the cloning and moving and deployment and all of those things we're going to do right inside our terminal here. So our dev setup is much easier. So what we're going to be looking at here is we have, as you can see in our picture here, we have our App ID instance here. Again, this is our OIDC grant type. We also have within our Red Hat OpenShift Kubernetes service, also referred to as ROCs here. So within this Red Hat OpenShift Kubernetes service, we have our modern UI, which is our front end, and we have our back end for front end and our API business logic. And we're going to see how all these pieces come together as we work through this. All of this is integrated within our IBM Cloud, and then we're serving to web and mobile devices. So this is just the OIDC grant type flow for the solution that we're deploying in this lab. I have kind of better, or I'll say larger images of how this works in the slides, because it can be a little hard to read, but we're going to take a look at this as we work through it. So if we look at the prerequisites for this lab, it says you'll need the following to complete the exercises in this lab. So we're all a little more familiar with Kubernetes. We're all a little bit more familiar with OpenShift. We only need, you know, some familiarity with Spring Boot and Node.js, which we touched on just a little bit, and an IBM Cloud user ID. So the first thing we're going to do is we're going to set up our environment. And let me know as we go if you get any errors or you have any issues. And we can troubleshoot as we go. But I have worked through this quite a few times, so I have a number of other people. So if you're having any issue, you probably skipped a step. So we'll go through this together to make sure we don't miss anything. So these are broken up into 7 exercises, and then next steps. You can take all of the things that you've learned here and apply them to maybe an application that you've already built, or building a new application from scratch on your own, and integrating App ID into that as well. So in our first exercise, we're going to set up our environment. So what we're going to be doing here is installing Node.js version 10. We're going to clone the modern UI and microservice security code from a Git repository. And again, we don't need to worry about the versions, since, again, everything's going to be installed here. We just need to make sure we go through the steps. So to make sure that everything is installed and done the way we need it to, all we need to do is click on the box, and it will copy it over into our terminal. So what I've done here is I have installed and verified Node Version Manager, which if you work in with Node versions at all and you don't have Node Version Manager, I highly, highly recommend you install on your local device. I can't, you know, push that enough. Will make your life so much easier. Okay. So as you can see here, well, there's sample outputs too. So if you're not getting an output that you should be getting, you may have skipped a step, but feel free to post in the chat if you have any issues. So the next thing we're going to do is we're just going to validate that we installed our Node Version Manager, or NVM, correctly. So as you can see, our NVM version here is 0.35.3. The next thing we want to do is install Node.js version 10.22.0. So I'm going to do that just by running nvm install and the version. Now this one doesn't run out, oh, it does run out automatically. So it just takes, I think this one just takes a second. But if anything's not running, you make sure to just click enter at the in the terminal here over here. You can type and do everything over here. So it's not that you can't type over here, it's just making it easier for you. Okay, cool. Sorry, just 1 second. My dog is okay. He's done. Okay, cool. So we've installed Node.js, and now we're just going to verify that we installed it and check which Node version we're currently using. Cool. So the Node version that we're currently using is our version 10.22.0, which is what we want. The next thing we're going to do is we're going to run git clone, and this is the Git repository we were referring to. So we're going to run git clone and cd into the project. So we're going to run both of these commands together. What we're going to see here is it's going to clone the repository, and then once it's been cloned, we're going to move into that directory with the cd cloud friendly app security command here. Cool. So the next thing we're going to do is we're going to install and set up IBM Cloud App ID. So this is what we're going to do this within our IBM Cloud account. So the diagram below here, which again, I've updated these in the slides as well. So this is just showing us what's getting provisioned within this exercise. So for each exercise, I'll show you where this is a little different. So here we're focusing on provisioning our App ID instance here. So we haven't done all of these other pieces yet, but we are going to provision our App ID instance. So what we're going to do, and it gives you a link here. So I'm going to open this in a new tab and just kind of show you what we have here. Maybe later. And again, this is a test account that I created just for this lab, just to make sure that, you know, everything is working as it should. So as you can see here, this is our cluster that was provisioned for us. So remember when we were kind of waiting for things to get set up at the beginning when we clicked the, you know, launch the lab. So this is what it did for us. It provisioned this cluster for us, and this is all of the information for this cluster. We have the cluster ID, the status, the version, all of the information here. It looks like we have 2 worker nodes for this cluster. So this is what this looks like, in just for reference, in the cloud, IBM Cloud portal when you provision an OpenShift cluster. You can also access the OpenShift web console from here. So what we are going to do, so for the OpenShift labs, and again, there's 6 of them, highly recommend once you finish this lab, dabbling in some of the other labs as well. They're really great, and they've just been updated this month as well. If you go to the very top next to manage, you will see a number, and then it says DTE. So this is actually the lab account. So the OpenShift cluster for the labs is provisioned under this lab account. And when you're done and finished with the lab, it will delete the cluster for you. So it's not just running and you don't have to remember to delete it. So in order to provision an instance of App ID, which we want to do so we can secure our application, we need to switch accounts. So you're going to click into your account. And as you can see here, there's no clusters on my account. So what I want to do here is I'm just going to click on IBM Cloud and go back to what you would normally see, your dashboard when you first log in. So I'm going to click Catalog here at the top. Just so you can see, this is all of the IBM Cloud products catalog. We have over 350 different products and services here. So what's nice is, look what's recommended for me. App ID, Watson Studio, Watson Assistant, Cloud Foundry. These are all things that I use all the time. So what we want to do here is click App ID. If it wasn't recommended for you, you can type it into the search bar here and it will pop up as well. Just wait for this to load. And if we're following along with the lab, it says it wants us to select the Washington, D.C. region. We're going to select the free light tier plan. And then at the bottom, what I like to do, especially since I'm normally working on an account with a bunch of other people, is I usually just add my initials. You can also just call this app ID lab, you know, whatever works better for you. I'm just going to call this app ID and my name. It's already set to the default resource group. And I'm going to click create. So this is going to provision my instance of app ID. All right, cool. So there's our lab. Okay. So we created our instance. Okay, so then the next thing we're going to do is we are going to click on Manage Authentication. Now, as you can see here, it says Manage Identity Providers. So as you can see here, these are all of the things that we can use for authentication. So let's say you want to add Facebook login or Google login or LinkedIn or, you know, some other type of custom login. You're able to do that here. So for this lab, what we're going to do is we're going to disable everything except for the Cloud Directory. Oops. Okay, so we have this here. The next thing we're going to do is go to our Cloud Directory on the side here. It's right under Authentication. We're going to click on Settings. And we want to allow our users to sign up and sign in using username and password. Allow users to sign up to your app. We're going to click No for now. And then the next thing we're going to do, if I'm not mistaken, is create, a user. So if you scroll down within this Cloud Directory, at the very bottom, it says Users. And we're going to create a Cloud Directory user here. So I'm going to call this test user. I'm just going to say IBM Cloud at IBM.com. And I'm just going to enter password. Okay. Now you're going to want to take note of this information because we're going to use this to log into our application once we're finished adding our App ID instance and deploying our application to our OpenShift cluster, and then connecting our resource to our BFF. So just take note of your username and password here. So I'm going to click Save. As you can see here, I've now created a Cloud Directory user. The next thing you're going to want to do is copy this name here. And what we're going to do is we're going to go to Applications along the side here. And we're going to add an application. So what we're doing here is we are binding our App ID instance to our application. So here we're just giving it a name. Regular web application is already selected. That's what we're going to go with. And then we're going to connect these from inside of our terminal. One thing you're going to want to note here is our information here. So there's three things we're going to need from here. We're going to need our client ID. We're going to need our secret. And we're going to need our OAuth server URL. Now, I'll reference this again and show you when we get to that step. But when we are copying these pieces of data over, we are copying just what's within the quotation marks. So we're not copying the whole thing. We're copying just what's inside here. Okay, so I have an application, my secret. Okay, cool. Cool. And then just a note to make sure that you're copying the secret, the client ID, and the secret, which is down here, not the tenant ID. I guess that's something that people have accidentally copied over and had some issues with. So the next thing we're going to do is we're going to set up our project namespace. So we're going to create our project namespace, and the secret that we're going to use are going to be used by our microservices that we're going to create later. So the first thing we're going to do, again, still in this terminal, we don't need to open another terminal or move around or do anything. We're just going to click this. And this is going to log us into our OpenShift cluster. So we're just going to give this a second. And again, it gives us the output here that we should see. So we should see a successful login. So you can see here, login successful. You have access to however many projects. Okay, cool. So let me just check and make sure we don't have any questions here. Okay, cool. So the next thing we're going to do is validate access to our cluster by viewing the nodes in the cluster. So let's run this, and we should see. Remember when we took a look at our, we have it open still? No. When we were taking a look at our OpenShift cluster that was provisioned by the lab account, and we had 2 nodes there. So you can see here we have our 1 and 2 OpenShift clusters. And these are, I'm sorry, our OpenShift cluster nodes. We have our 2 nodes here. So the next thing we want to do is create a project namespace. So I'm going to click here. So we have this command OC, and again, we're using, normally if we were doing this from the command line, we would use the IBM Cloud CLI to access our account, and then the OpenShift cluster CLI, which is designated by this OC here. So just if you're wondering what we're doing here and what we're seeing here, the OpenShift cluster CLI is already installed, so that's what we're using here with these OC commands. So as you can see here, we have OC new project, cloud-friendly security, and as we can look over here, okay, we have now using project cloud-friendly security on server. There's the server. Says we can add applications to this project, which we can also do from here. We can add more applications to this cluster with our new app command. Here's an app. This is fun. I'll probably play around with this weekend. We have a new example application in Ruby. I've worked a lot in Ruby prior to coming to IBM, so that's exciting. If you've worked in Python or Ruby, this would probably be a good example app to look at too. Cool. So you can also use Kubectl to deploy a simple Kubernetes application, which we have here. This is a simple Hello Node application from an image here. So now that we've created our namespace, we're going to copy the template app ID.env to our GM4 cap mod app NV. So this application that we cloned earlier. So let's copy this template over to our apps env file. Okay. And now what we're going to do is we're going to actually edit this env file. So this is what I was talking about when we want to make sure we don't have any issues here. So go ahead and click here. And then if you click over in your terminal here, you can make changes right in the terminal. So the first thing I want to do is get my client ID. So if I go back here, client ID is the first part. And again, I'm not going to copy the quotes. I'm going to copy just what's within the quotes. I'm going to paste it here. Okay. Next thing I'm going to do, and you're going to want to push up and down arrow. Clicking in isn't going to work. So I push down arrow. I'm going to backspace. Now I want the client secret. Again, we want to make sure we don't accidentally get this one. We want the secret, which is right here. Okay. Paste it in here. And then I'm going to go down arrow to the next row, and we have OAuth server URL. We have that right here. And again, this is going to be everything inside the quotes. The quotes will break it, and it will not work if you include them. So cool. So the next thing we want to do is Control X. We get a message here. Save modified buffer. We want to say yes. And then it's going to ask file name to write. We can press enter. Perfect. So, okay. Now what we want to do is we want to create our app secret on OpenShift. So next thing I'm going to do is run this line of code. And this is going to create our app secret on our OpenShift cluster. So as you can see here, we have secret for our GM4 capmod app created. Then we want to validate that secret on OpenShift. So we're going to run this next. As you can see here, again, these OC commands with our OpenShift cluster CLI. So we're going to validate by running this OC describe secret and the app name. So as you can see here, we have the name, our namespace. Remember, we created a namespace earlier. Type opaque, and then we have our client ID is 36 bytes. Our client server is 48 bytes, and our OAuth server URL is 81 bytes. Perfect. So the next part we're going to look at here. Let me close these, move this up a little. There we go. Okay, so we set up our project namespace. Now we're going to deploy our resource microservice. So in this exercise, what we're doing is deploying a resource MS microservice application to OpenShift. Excuse me. So this microservice is secured with a JSON web token passed in the authorization header. So this leverages the issuer URI, which is going to receive that JSON web token key set from App ID in order to validate the JSON web token. So again, the JSON web key set, JWKS, is going to retrieve, the issuer URI, the issuer URI is going to retrieve that JSON web key set from our App ID instance that we just created. And it's going to use that to validate the JSON web token. So the JSON web key set is going to provide the public key that's going to verify the JSON web token's signature. Also, the resource MS microservice is going to validate if the JSON web token is not expired. And it's going to leverage the issuer URI to validate that JSON web token has the appropriate issuer information. So I mentioned we were going to see some updated diagrams. So this diagram is showing what's getting provisioned within this exercise. So what we have here is we have our Red Hat OpenShift Kubernetes service. This is our cluster. that we've provisioned. And what we're going to be focusing on here is the API business logic that's communicating with our app ID instance. So these are the pieces that we're working on here. So this is showing the resource MS and the dependent component highlighted in purple here. So we have our, in this rocks here. So again, I have these images kind of broken up in the slides, so they're easier to see. So as you can see here, the pieces that we're focusing on right now is the backend for front end here is going to validate the pseudo token and pass the OIDC access token to the microservice. The microservice validates that token via the JSON web key set and or the OIDC provider API. And then the microservice is going to return a response. So these are the pieces of the architecture that we're focusing on here. We also have the microservice code, which shows the associated YAML snapshots. And these are kind of the real key components of the microservices, JSON Web Token security. Excuse me. So we have the resource server config Java file. Excuse me. We have the application YAML here. Oops. So you can see here. Here's where our OAuth server URL comes in. So the first thing we're going to do is build and deploy this resource microservice to OpenShift. So let's go ahead and do this. Should take 1 or 2 minutes. Shouldn't take too long. Hopefully the demo gods are acting in my favor today. I've run this application, probably this, excuse me, this lab, probably about 10 times. So we'll cross our fingers and hope for the best. So I want to check in with you all and see where you all are at. If you're stuck anywhere, if you're getting any weird errors, if you have any questions, feel free to throw them in the chat. There's also a question, ask a question section at the bottom here. Okay. All right. So what's going on here while we're waiting for this? So this is where we're creating our OpenShift resource descriptor. So this is actually building that resource microservice we talked about. This is also starting the source to image build. Remember we talked about that earlier. Source to image is an automated image build from our source code. And then it's deploying our microservice to the OpenShift cluster. Perfect. Now what we can do is just confirm that our resource microservice pod is running by running this code. As you can see here, it says it's running and the amount of time. Perfect. So the next part of this, now that we have deployed our resource microservice, we're going to deploy our BFF microservice. Remember, backend for front end. So let's go here. So the backend for front end microservice is going to provide 2 core application features for us here. The app security with session management and our service proxy with our JSON web token security identification propagation. So this diagram below is going to depict what's getting provisioned with this exercise. So as you can see here, we're focusing on this backend for front end part of our architecture here. So what's happening here within our OpenID Connect Authorization Grant Type, or that OIDC we talked about, the OIDC provider is going to redirect to the backend for front-end with our authorization code. The backend for front-end request is going to request the OIDC access token from the OIDC provider with the authorization code and redirect URL. The OIDC provider is going to provide that OIDC access token with an optional refresh token. And the backend for front end is going to store that OIDC access token and or refresh token with session management. The BFF redirects to the UI SPA with the pseudo token session management cookie. The SPA is going to call the BFF with the pseudo token cookie. So let's go 7. Here we go. It's going to redirect to the UI here in our browser. And then the SPA here is going to call the BFF with the pseudo token cookie. So now we're here. And then the BFF is going to validate the pseudo token and pass the OIDC access token to the microservice here. So we have our microservice back here. And then the last piece we're going to be looking at here as well is the microservice is going to return a response. So what we're going to do here is, again, we're going to build and deploy our modern BFF microservice to OpenShift. So we deployed our resource microservice. Now we're going to deploy our BFF microservice. So what's happening here is we're creating our OpenShift resource distributor, building the microservice, again, starting the source to image build and deploying the microservice to the OpenShift cluster. So same thing we just did with the deploy resource microservice. And that'll take just a minute. And then we'll be able to confirm that the modern BFF microservice is running. So let me just check here, make sure we don't have any questions. Okay. Sorry about that, just a second. Sorry about that. They're looking for any place to bark at. Okay. Perfect. So now let's just confirm that our modern BFF microservice pod is running. Perfect. As we can see here, we can confirm that it's running. So now the last piece we're going to deploy here, we're going to deploy our modern UI single page application. So that's the last part here. So a single page application, what we're referring to SPA here, is just a web application that fits on a single web page. It provides a more fluid user experience, similar to a desktop application. So this is a Node.js Angular UI single page application, and we're deploying it to OpenShift via NodeShift. So if we look here in the architecture, we're focusing on this modern UI within our OpenShift Kubernetes service here. I'm sorry, our OpenShift cluster here. So the pieces we're focusing on here is the browser is going to get that UI single page application. The user is going to click login, and it's going to be redirected to the OIDC provider login page, and then the user will authenticate against the OIDC provider. So these are the pieces that we are deploying to our application, deploying to our cluster here. Okay, and we can see the pieces of our application here. So we have within our app components file, we have our app config service within our app component. As you can see here, we have our authorization through App ID, and as you can see here, we have a login and a log out. So the modern UI single page application authentication security is not going to display until can activate returns true. So for instance, when we're going to click a login button on our application before it's going to display any of the information on our page. We're going to make sure that we are authenticated to view our information before it's going to display anything to our application in the browser. So again, we have our app module, we have our routes here, and then we have our shared AuthGuard service here as well. So what we want to do here is, again, build and deploy our modern UI microservice to OpenShift. So we're going to run that. So again, this is creating our OpenShift resource descriptor, building the Node.js app, and starting that source to image build that we saw in the previous two microservice deployments. And it's going to deploy our Node.js application to the OpenShift cluster. So this will take just a minute. So we get this prompt. Would you like to share anonymous usage? We're just going to put no. And I'll wait for the rest of it to run. And then the last thing we're going to do is confirm that our modern UI microservice pod is running. And then we just have one more step left, one more piece left to our application before we'll be able to test out our login. Okay, it's moving along nicely. How's it coming for all of you on your end? Things going good? What's really nice about these labs, specifically the OpenShift labs, is it's really nice to not have to spend an hour or two debugging issues with your dev environment and being able to get in and just start building and playing around with things and getting things actually up and running. So this should just be about finishing up here. And again, if you have any questions, feel free to post them in the chat or in the Ask a Question section at the bottom. Okay, I think we're just about done here. I hope the weather's good where all of you are at, because it was snowing here yesterday. My car door was frozen shut this morning. I had to like yank it and break the ice to open it, which is ridiculous because it's sunny out. It doesn't even make any sense. We always get one good snow in April, so hopefully we're done now. So there we go, perfect. So let's just confirm that our modern UI pod is running. Perfect, we can see here that it's running. So the last part we're gonna do here, again, so the piece we're looking at here, so what we wanna do is first we wanna retrieve the BFF, that backend for front end, and the UI external routes as environment variables. So let's run here, perfect. Then we're going to update the modern UI web application environment variable to leverage the modern BFF external route. for the single page application web API REST calls. So we're going to run here. Again, you see that OC command here. We're going to validate the updated modern UI web app BFF URL environment variable. Perfect. So see, port 8080. Okay. Now we're going to update the modern BFF microservice environment variable to leverage our modern UI external route for security redirects. So again, we're running these OC commands here. The last piece we have here, we have a few more steps. We're going to hook it up. So we're going to update them. Let me make sure. Let's see. Set. Modern BFF U address. Yep. Okay. Next, we're going to validate the updated modern BFF microservice UI redirect URI environment variable. Okay. All right. Now we're going to display and copy the BFF login external route. So this is kind of the last piece we need to hook up here. So let's run this. And as you can see, we have here this echo modern BFF login route. I'm going to copy this whole thing here. So what we're going to want to do is configure the app ID OIDC Authorization Grant Type redirect URL. So we're going to go here. We're going to go to Manage Authentication. We're going to go to Authentication Settings, and we're going to add this to our Add Web Redirect URLs. So we need to worry about this stuff down here. We're going to add it here and click the plus button to add it. So here it's added. Perfect. So success here. So the next thing we're going to do, is and here's a picture of where to paste it to if you're not sure. We're going to display and copy the UI external route. Okay, so we have the modern UI here. We're going to take this link and we're going to copy and paste it within our web browser. If you've gotten this far, congratulations. This is a really big step. So this is our modern UI application that we've deployed. This has our resource and our BFF microservices deployed. Our app ID instance is integrated within our application and deployed to our OpenShift cluster. And this is our live application. So this is our application that we just built, excuse me, and deployed to our OpenShift cluster. So as you can see here, it says greeting, log in to see your greeting. Excuse me. So when we're talking about single page applications, we don't want to display this information until we can validate our user, right? Until we can authorize and authenticate our user. So we can click our login here. Now, again, this is really nice. Any of you that have built applications before, when you're dealing with authentication, app login, you're dealing with CORS issues and all of these things, right? What's really nice is, excuse me, you can add, like I said, Google, Facebook, LinkedIn, any type of authentication you want to use. You can also do custom authentication and add a logo. And all the UI is here, right? Like, you don't need to worry about this. Like, this is a whole piece that you don't need to worry about that's provided by your App ID service. So, again, let's look at our, we have our IBM Cloud, and then our password. Perfect. You have successfully logged in. Click details link to see your greeting. So let's click details. We have our ID, our content, and our host name. Excuse me. So what we did here is the browser is redirecting us to the modern UI single page application. and then displaying the following message, showing our ID and content details information. So this is like a very basic way of really focusing on how to get up and running quickly with OpenShift, how to quickly deploy a single page application, and how to integrate IBM Cloud's App ID quickly and easily into our application. And again, like I said, the pieces are already here. With App ID, it's really nice because, like I said, you're not building all of this UI out to add authentication. Those pieces are there. You can just add any extra information, upload any images you want to use. If you would like, I'd like to extend this as into a V2 part for anyone that's interested. So go ahead and post in the chat if you'd be interested in doing a workshop where I show you how to create an application from one of our IBM Cloud Starter Kits. We have a whole wide range of application, technology, tech stacks and different technology languages to choose from, and get things integrated as well. So if there's anything else that you all would like to see, go ahead and post in the chat. I'd love to get your feedback. You all have comment access to the slides as well. Let's see, sorry. Let me, oops. Let's see. So for all of you that have made it this far, congratulations. You have created and deployed your first OpenShift cluster. You've built and deployed your first resource and backend for front-end microservices, and your first modern UI application, microservice application as well. You've integrated an App ID to secure your single page application, and authenticated your first user to access your application. So great job. I know it's a lot of material, it's a lot of things, but I want to make sure that everything that we use and that I introduce to all of you is very user-friendly, developer-friendly. I'm a developer. I'm not a data scientist. I don't, dabble deeply into security all the time. So I want to make sure that you're all able to be well versed in all things that are important to creating your applications, whether it be for personal use or enterprise ready, but still be able to focus on your work as a developer and really building out the content of your applications. So congrats to all of you. The last thing I would like to leave you all with is, let me go here. If you would, here we go. If you would be so kind, I would love to get feedback from you all. I have a very quick 2-second survey. It's literally 2 questions. If you would like to give feedback, please feel free. I would also like to invite you all to follow me on LinkedIn, and if you'd like to see more content, whether it's OpenShift, security, lots of data and AI stuff, feel free to check out my YouTube channel. Again, we have all of the resources here at the end. So we have more authentication resources. We have App ID resources here for you. Those certifications I talked about that I think are really, really beneficial, especially for younger developers just starting out in your first couple of years, really leveling up your cloud native skills. And you, again, feel free to follow us on all of our social channels. And again, feel free to reach out to me if you have any questions. If there's anything else that you'd like to see, you can leave me a comment in the feedback. You can send me a message on LinkedIn. You can also feel free to comment on the slides. Anything that's not clear, anything you'd like to see, I'm here to help all of you level up your skills, your technical skills as developers. So if you have any questions, feel free to reach out. And I'd like to thank you all so much for coming, and I will see you next time. Have a great rest of your week.